Today we are going over decimals. Who here knows how to work with decimals? Yeah? A little bit? Hey. So we did kind of go over decimals already in the quarter, but not so in-depth, right? And we're getting prepared for what's to come with fractions next week. Decimals, actually this week too. Decimals and fractions, they are very much alike. You got to know one, you could master the other easily. But if we could go back all the way to the first quarter, the first day of the quarter. The first day. Do you remember what we did on the first days of the quarter? You don't remember the whole 426, and I told you what is the place value of each of these? Well, how about we review very quick? Tell me. What's the place value of the 6? Ones, right? What about the 2? And the 4? And so on and so forth, right? And then we also went over rounding, right? If I were to say round 426 to the nearest tens, what does it become? Cool. So that was when we were getting familiar with the place values and rounding and which number is greater than what number of whole numbers. That's all we were doing, right? And then we went on to how to multiply, divide, and all this, add and subtract whole numbers. Now we're kind of coming back to that, but now we're looking at the part that we haven't worked with too much, which is decimals, right? If you recall, 2.375. Do we remember, I kind of went over it very quick, do we remember what's the place values of all these numbers?
It's still the same.
How so? Give me...
5 is still 1, 10, and 100.
Okay, I could see that. I could see why, but yeah, keep in mind we haven't gone over this. I kind of very quickly touched on it, but then I quickly backed off and I said, that's to come in later weeks, right? So you guys want to take out your notes and start writing this down, because this is the tricks with decimals, the place values and rounding and all this and all that. It's the same thing. Where is Nick, do you have a pen? Okay, well, you got paper? Cool. So, place values. Let's say I added more here. Let's say I added 122, right? This is obviously 122.375, right? If this 0.375 wasn't there, this was just a standard old whole number, right? We know the place value of 122. We already know that. What is the place value of the 2? No, so this is the first lesson. That's the ones. That's the ones. Just pretend, just for a brief second, pretend this 0.375 wasn't there. What is it, the thing that you just said earlier? The 6 was the ones, oops. The 6 was the ones, the 2 was the tens, and the 4 was the hundreds, right? Well, same thing here. except we have a 0.375. But this is still part of the whole number. So the ones is still your first digit, in this case after, in front of the decimal. This is your ones. This is your tens still. And this is still your hundreds. And if they had more numbers, same old, same old. It's all going that way. But what we're learning today is what are the place values of everything to the right. And this is where you guys start writing out your notes. You guys want to treat this first digit in front of the decimal always as your anchor point. All right? Treat that as your anchor point. It's set in stone. That will always be your ones place. If this one right here is your tens, do you know what this 3 is right there? Very, very similar. What's the difference?
There's no one. Well, the ones before the.
This is your anchor point. That's always going to be your 1 right there. The difference is literally between the tens and the tenths. It's just that th at the end, right? If this is your hundreds right here, what do you think the 7 is? Hundredths. So we did go over word problems last week, right? Or 2 weeks ago. And how it's important to always look at the question. And this is a beautiful class of mine that everyone is taking the GED, right? Everyone's taking the GED. Nick, are you taking the GED? Okay. So it's important that everyone keeps notes to always read the question. Always be prepared for what the question is trying to ask you, right? And when it comes down to rounding, it's important that you keep note of whether they're asking round to the nearest tens or round to the nearest tenths, round to the nearest hundredth, round to the nearest hundredths. It's that TH that you guys have to keep note of, right? Because that's going to dictate where you're going to round from. Are you going to round from the tens or the tenths? Very quick, what is the 5? What's the place value of the 5? Yep. Let's add in some more numbers just for the heck of it. What's the 6? 10. I should add a TH to that. And then the 6 being 10,000ths. Sorry for the handwriting. 2. What's the 2? Yeah. Same thing over here. What if it just continued on with whole numbers? The same thing. Hundreds, 10,000ths, 100,000ths, or 100,000ths. And this one being 100,000ths. I'll let you guys write it down. It's fine. And then after that, obviously, the millionths, right? So, the place value, a little trick I taught everyone. You kind of want to think of it as a mirrored reflection, right? If this is the ones, and it will always be the ones, it's kind of that, like I said, that's the anchor point. This is a mirrored reflection. All this is just a mirrored reflection of all that. The tens is here, the tenths is there. The hundreds is there, the hundredths are there. Keep note of that. And we're going to be messing with a lot of word problems this week. And it's going to be important, again, to start getting accurate final answers in terms of our rounding. If it says round to the nearest thousandths, you must round appropriately. correctly. If not, wrong. So that's the place value, right? Now, do you remember how to round? Let's stick with the same example. 2.375. What if I said round to the nearest tenths? What does it become?
2.3.
Yeah. So, if we want to very quickly review, because we did go over rounding, whatever the question tells you, wherever it tells you to round, you must go to it. So if it says round to the nearest tenths, the most important part is to go to that place. So tell me first off, what's the tenths place?
3.
The 3, right? So you must indicate what that is, or where it's at. Once you've done that, what must you do? Someone else. Yes.
Just whatever, like round to what's like near, like it's like in that case it would be 40.
Well, yeah. So I'm pretty sure you already know it. How would you say it? How would you explain it? The way we explain it.
Oh, so like if it's like if it's less than 35, like as an example, then it would be just 30 rounded it to the nearest tens.
Good.
And if it's more than 35 or 35, it would round it up to about 40.
Cool. So nice. The way we went over it last time was, hey, look at its buddy, right? Do you guys remember that? Look to the buddy to its what? Its right. Right? So you just look to its buddy. And then you ask yourself, does that 7, what rule does it fall under, right? Because like you said, there are certain rules. If it's the 1 to 4 rule, if it's from 1 or 4 or anything in between, this place value, the one that it told us to go to, will stay the same. Do you remember these rules? As in, if the buddy falls under that rule, the 3 stays the same and then the rest becomes 0, right? But there is another rule. If it falls under 5 or 9, that means the place value that they told us to go to goes up by 1, right? And in this case, there's the tenths. You look to its right. It's a 7, which means it falls under this rule. So 3 points. That one has to go up by 1, 4. Now, Veronica, you did say 0, 0, right? You don't need it. You don't need it. You know why? Because what does every number have in front? An infinite amount of zeros. What does it have behind? An infinite amount of zeros. It's just not seen. It doesn't need to be there. So that's why we just get rid of all the zeros. So let me go over it one more time because I kind of made it a little sloppy. But, you know what? Let's just do another example. How about that? So, question. Round to the nearest hundredths. What are you going to do first? Where must you go?
5.
Cool. Look to its neighbor. Look to his little buddy to the right. Does this number to the right of that place value, Does it fall under the 1 to 4 rule or the 5 to 9 rule? This one right there. Does it fall under 1 to 4 or 5 to 9? 1 to 4, right? So it's less than 4. So that's important because if we remember, the 1 to 4 rule tells us our place value is going to stay the same and the rest becomes 0. So all this is, rounded to the nearest hundredths, is 13.75. The rest becomes 0, but like I said, you don't need to put the zeros. 13.752 rounded to the nearest hundredths is 13.75. What if the question was different and it said, round this answer to the nearest tenths? Well, tell me, where's the tenths place?
7.
Look to its buddy. What rule does that one fall under? Is it my 1 to 4 or my 5 to 9? So, what happens to my 7? Does it stay the same or does it go up by 1? Goes up. Yeah, because the 5 to 9 rule says it has to go up by 1. So 13.75 rounded to the nearest tenths is, 13.8. Any questions on the rounding? Sure. Yeah. So this was, it's almost an exact replica of what we went over the first week. It's just place values and rounding, right? We all know how to do that. We all are masters at it now. The only difference is now you're working on this side of the numbers, on the decimal sides. And just like the first week, when we compared numbers, this is no different. You got to watch out for the certain numbers that try to trick you, such as this one. Let's say you're given a question like this. And the question is very simple. Which one is the greater number? Who here thinks is the first one? If you did, you'd be correct. If we remember, you don't want to fall for the trap of just seeing extra numbers and then thinking that the more numbers is the bigger number, is greater in value. That's the last thing you want to think of, right? And the reason being is if you line it up, if you got this one, let me just bring it over. And you put them next to each other. Sure, this one might have more actual digits, but what did I say each number has an infinite amount of? Zeros. You could fill in that 0, right? Don't fall for their trap. You could clearly see that 1,000, or this isn't 1,200. You could clearly see that 0.1250 is bigger than 0.1092, right? It's almost as if you want to think of it as 1,250 and 1,092. So now we're going back to our famous zeros, using zeros to our advantage, and placing it in the places that help us visually see everything. Um, yeah. Do we remember, we did kind of, did we go over adding and, no, we didn't go over that. This is going to be the week in which we go over the operations with decimals, right? So we're actually going to be learning how to multiply, divide, add, and subtract decimal numbers. When we were learning how to divide by hand, we kind of went into the intro of decimals. Do you remember how we no longer use the remainder of something, and we just continue? Cool. Any questions on the place values, the rounding, and just seeing decimal numbers for the first time? Any questions? Good. That's too messy. I do have something better that I could bring up. I don't know if I have it anymore, but it's fine. In the worksheet that I'm handing out, in the front they do have the little place values that you guys could memorize, but you guys already know the place values of whole numbers is the same thing. Just think of that the ones place as the anchor point, and the rest the same thing, just mirrored. Tenths, hundredths, thousandths, 10,000. We're going that way now, all right? So that's what we're going to do today. Yeah.